welcome you to my lesson for today, where we are going to be looking at your mathematics. So ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say is massively, massively, massive. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, honorable members, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, honorable members, on that one. So if you guys remember, when was it? This week on Tuesday, we were doing some classwork, and there was a point where towards the end, I just noticed afterwards that I was cut off because my battery was on 10%. And what I realized was that the last question was copied incorrectly. So that is why it couldn't give the correct answers. But otherwise, we are not going to continue from there. We will now start with something new. So let's see. This is what we're going to be doing, honorable members. I'll just write that down and say addition and subtraction of powers with numerical basis. Honorable members, I would like for you to take note of what I've written there. Addition and subtractions of powers. What is a power? A power, it is something that is a base and an exponent. This is what we call a power. So according to that statement, I'm saying additions and subtractions of powers. So that means you're going to be having a base and an exponent, where it's either you add or you subtract another base with an exponent. It does not end there, honorable members or members who are honorable. I am saying with numerical basis. So that means our bases are going to be the numbers, numerical basis, which could be, for example, 4, it could be 2, it could be a number which is then going to be a base. Very, very much important, honorable members, on that one. Okay, then it's fine. So I'm just going to give you guys something that I can very quickly work it out. Then from there, I will give you some problems to work out. Maybe let me just do 1 or 2. Then I'll give you something to work on. So the question that I might give to you is to say, show that show that 2 to the exponent x plus 1 plus 3, that is multiplying 2 to the exponent x, it is equals to 5 times 2 to the exponent x. I'm just praying that I copy all these problems correctly, because the challenge now is, if I do not copy it correctly, then it is going to give an error. You will notice that the calculation, it won't be not necessarily an easy one, but you will just notice that it doesn't get us to the final answer. So when they say show that, you can decide to actually work with the left hand side, because you can see that it is the one where you can try to simplify that left hand side to show that it is actually equal or the same with the right hand side. So let us see. On the left hand side, we have 2 to the exponent x. Obviously, what we are doing, it is more like to separate it. So we separate that term, and then we can work on this one. If you can see that one, there's nothing much that we can do on that one. So can you guys see that was actually our first step? On our second step, when we are dealing with additions and subtractions, this is where you will always factorize or take out something as common factor. So that means you can take out 2 to the exponent x to the outside, and then what remains after you take it out, it is just that 2, and then you have that same sign. Then what remains there, it is 3. So can you guys see, you end up having 2 to the exponent that, 2 plus that, it is 5, which is the same as 5 multiplying 2 to the exponent x. So can you guys see, you did show that the left hand side, it is equals to the right hand side. Okay, then it's fine. Let's now look at another example. So remember, honorable members, this type of a lesson, it is not one where you and I ask each other some questions. Actually, it's a one way. I'm the one who's giving you guys the problems to work on, and then you answer those problems. But yourself on your side, you are not able to ask me the questions verbally. So this is not the platform where we do that. That one, it is done on the Zoom lessons. You need to check your timetable where it will guide you in terms of when you're going to be attending the Zoom lesson. So you just check in our WhatsApp group. So let us see. Which one can I use as an example? Maybe let me try make use of this one. Which one am I going to try and use? I'm here trying to think, honorable members. Okay, maybe let me try use this one. That was number 1. Let's say they say express 9 to the exponent x minus 1 plus 3 to that as a single power expression, as a single power expression. So can you guys see, you have that term, you have that term. This is not a single power expression. So it's like they just want something that has a base and an exponent. So this is how you can try to work it out. Let us try to expand that 9 or rewrite it as 3 squared, and then you still have that. So obviously on this side, what you have is 3 to the exponent that. Obviously, you know that that is multiplying that and that. So that means you've got 3, that times that, it is 2x, that times that, it is minus 2. This is a plus 2 to the that. Okay, let us now see. What if we say 3 to the exponent 2x? We know that this is the same as 3 to the exponent negative 2 plus 3 to the exponent that. Why did I do that? It's so that I can try take out something as a common factor. What if I take out this as common factor? So that means on the outside I've got 3 to the that, inside I've got 3 to the exponent that, and then plus, obviously, there is an invisible one there, which is the one that I'm going to write there. So all that you need to do is to punch all of this on a calculator. Let's check what that is. Let us say 3 to the exponent negative 1, and then you plus it with 1 is the same as 10 over 9. So it's more like this thing is 3 to the 2x, 10 over 9. Yes. So finally, that means finally we have our coefficient being 10 over 9, 3 to the power of 2x. So can you guys see? You have written that as a single power, as a single power expression. So now I'm going to give you guys the last example. Then from there, I'm going to be the one now asking the questions, where not necessarily questions, I'll just be giving you guys some problems to work on. So now let's see. Let us say we've got 3 to the exponent x minus 2. Then we minus, let us say 3 to the exponent x. The whole of that, we divide it by 3 to the exponent x. Let us say plus 1. Let's also minus there and say 3 to the exponent x minus 2. So remember guys, addition and subtractions of powers with numerical basis. So that means there it's actually powers, yes. So now let us try to expand. So that means in this case where you have an addition or subtraction, you will always try to break it. So it's like you do a reverse of what we were doing when we were applying the laws of exponents. Like we know that if we have, let us say, a to the exponent x multiplying a to the exponent y, we know that this is the same as you express the base as the same because the bases are the same, then you add the exponents. But in that situation, it's like you are given that in this format, you now need to reverse it to that. That's what we are actually doing. So how do you know if you need to reverse? That's if you have a sign of a minus or a plus, minus or a plus. So straight away, I'm going to break that one and say this is that. And then this one, I don't need to break it. It is as that. This one, yes, I can break it. And then you have invisible one there. You can write if you like. And this one, you have that. And then this one, you have that. So can you guys see? So it's more like the first step is to break. I need a different marker there. I'm hoping that I could find one. Just so that you have a sense of what I do. The first step, you can see what I did was to break. The second step that I'm going to do is to factorize. Yes, that's what I'm going to do now, to factorize. I hope this thing I see is moving, but I hope it's not making it black. Okay, so now when you factorize, you take out something as common factor. This it can be taken out as common factor. You have that invisible one there, can write it there. And then now you can still take out that as common factor, which is that you have your 3 to the 1 minus 3 to the exponent that, negative that. Then I think what you can do, it is to therefore punch that on a calculator. But one thing for sure, we do know very well that this will cancel with that. I think that one we know. Oh yes, you see now, I just noticed something. Even though in this case it is not that much of an issue. Actually here it was supposed to be a plus sign. So let's see. If it is a plus sign, it does not affect what I've done up to this point. It does not affect what I've done up to this point. So that means all that you need to do, you know that is, it's more like 3 squared is 9, you minus 1 over what is that 1 over there, that is 3 minus, if you punch this one on a calculator, trust me, it is going to give you 1 over 9. And then you can just punch all of this on a calculator. So let's see, it's more like you say fraction pattern, 9 minus 1 is 8, you say 3 minus, then you say 1 over 9, it gives you 36 over 13. Yes, 36 over 13. So that means the problems that I'm going to give you, you might need to work them out such that you just give me the final answer. Hope you guys were listening there, and I hope you guys I hope you were able to gather all this information. Let me not end it there, honorable members. I noticed there's something very much important, and now I wonder if it is worth it to include it in this lesson. Maybe it is. Maybe it is. Just so that we have a lesson that has all, let me just include this one being the last one. So here, this is where you need to simplify. What are we simplifying? You simplify 3 to the power of 2x minus 1 over, let us say 3 to the exponent x, let us say plus 1. Yes, I've copied it correctly. Yes, what you need to do is to simplify. Remember, addition and subtractions of powers with numerical bases. The best thing to do this one, honorable members, this two, it tells you more. It tells you more. Remember that if you have a squared minus 1, this thing can be factorized, honorable members. It can be factorized and be written as what? Will it not be a plus 1 and then again a minus 1? Let's try to apply this principle there. So that means you will firstly need to rewrite that nicely. What do I mean by nicely? You can say 3 to the power of x, and then you say squared, you have minus 1. Just says my battery is on 20%. Okay, hope it won't kick me out. So let's say now 3 to the exponent x plus a 1. So can you guys see that a there, it's like it's 3 to the exponent x. So that means actually this thing can be factorized in that format where you say you actually have 3 to the x, you can say minus 1, and then you say 3 to the x, then here you say plus 1, and then the whole of that, it is 3 to the exponent x plus 1. I'm not sure if you guys notice something, but this is what I noticed. This thing, it is the same as that. So that means this, you can cancel it with that, and then you end up having just 3 to the exponent x minus 1. That means this is your final answer. The reason why I had to do this one, honorable members, it's because I wanted a lesson that has everything and not having some parts. So I'm just hoping that I'll be able to continue until we finish the business for today, but I doubt. I will definitely need to check my external power. Otherwise, we will not be able to survive with 20%. Okay, that's all, honorable member. Remember, guys, just to confuse the enemy, there is that button of a liking there. Just click on that button, honorable member. I'm not sure which enemy we are going to be trying to confuse, but let us try to confuse whoever considered the enemy. Which one am I going to give to you guys? Because I notice. Okay, I think this one we're going to do it this way, honorable members. Maybe let me look for one which may be or which may look a bit complicated. Okay, I think this one. 9. Okay, this is what we do. We show. We start by showing. Show that. Show that 9 to the exponent x plus 3 to the exponent 2x plus 1, it is equals to 4 multiplied 3 to the exponent 2x. So how you give me an answer to this question? You just comment and saying I got it correct, or you just comment by saying I'm struggling. In that way, I'm going to have an idea of whether to do the corrections or not. So if you say I got it correct, then we continue. For someone who says I got it wrong, then very quickly we do the corrections. I think as soon as you've done that one, let me also give you this one, just so that just so that just so that I'll have enough time to go look for external power. Simplify. Yes, we show that for the first one. Let us say number 1, and then number 2, you simplify. I'm just thinking of which one to give you guys. I'm just thinking of which one to give you guys. Maybe this one. Yes, I'm just trying to look for those ones which look a bit challenging, just so that we can struggle and maybe struggle together. Yes, there you go. So what you do is to comment and say number 1, I got it correct, and then you say number 2, I'm still struggling. There's Larissa says I got the first one. Let's move on to the second one. Yes, that's how you're going to respond. I'm going to check, look for external power. Okay. I am back, and luckily I was able to get an external power, a power bank. So let me just connect there while I'm waiting for you guys to check. So remember, guys, for the second one, you just make a comment to say I got it, or I did not. Oh, okay. No. Now I see. For that second one, you won't be able to say I got it or not, because what? Because it's not like you are proving or you are showing. Then it's fine. Let's quickly do it. Then I'll give you something. Let's quickly do it. But it seems like most of you guys got the same answer. But let's do it and check if I'm going to manage on that one. 2 to the third minus 1. Yes. So remember, guys, this is a live recording. As soon as this is done, it's going to post. So you can watch this as many times as possible, just to remind yourself of all that we have done. I'm also going to post it on our channel, where I post all the recorded lessons. So let's see. Did I copy it correctly? I think so. Huh? So now let's see. You have 2 to the that and then that. I think what did I say? I said I'm going to expand it. Guys, this thing is the same as that. Again, it can be written as that. Actually, it is supposed to be written as that, or otherwise you can write it in other way. Okay, I think this is going to be a learning moment for you guys. This thing, always when you have 2x or two letter there, just be aware that you can still write it as a letter and a letter. Why? Because you know that it ends up being x plus x, which then takes you back to 2x. Otherwise, you can write it as 2 to the x, and then you take out that as common factor. No, not as common factor, but you can take out that 2 or take that 2 to the outside. It all depends on what you are trying to achieve. Okay, so now let's see. I've got common factor there, so that means I can take out that as common factor. I'm going to remain with that. So I took out that, I remain with this one, and then minus this one, you remain with an invisible one there. So that's why I'm writing 1 there. Then if you say over, you remain with 2 to the x minus 1. Hey man, it seems like this thing, it's exactly this. Yes, you guys are correct, because that cancels with that, and then you remain with just 2 to... Okay, guys, you got it correct. You are 100% correct. So what I'm going to do now, it is to remove all of that, and then from there, I'm going to give you some more problems to work on. So let us see, where are those problems? Where are those? I have those problems. I had those problems. Okay, then it simply forget about that one that you are referring to. I think we did corrections on that one, and you will find it. So this is just to avoid a repetition. I will add you to a classroom where we do this very much easier. So guys, an exam. So time is hope. A noted honorable member. Let me do that. And you punch it, then you get an answer. Okay. You are in exam, honorable member. You should be honorable break. To to the x. Can you guys see? And then minus k on your side. I think while I'm waiting for that, try and work on for that one. I think it is okay. If it's not okay, it's okay. If it's not okay, it's fine, it's fine, it's fine, it's fine. If it is not okay, then cut this lesson short. Say you are breaking, okay. There I'm having, say, I think your network is bad, say you keep breaking, say internet connection seems to be on the free, say you're breaking. Okay, 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 okay. I did note that. So let us try for the last time. Let us try for the last time, and then from there, I will then have an idea as to whether we can cut this lesson short. How about now, honorable members? Still the same, nay? Guys, is it still breaking? Is it still breaking, honorable members? Maybe it is because I am not instantly able to get a response from your side. So this is an indication that, okay, someone is saying no, it's fine now. Okay, 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 okay. Then if it's fine, let us see. It's right now, no. Okay, okay. Then let's try very quickly to work on that one. Let's see what the answer is. Let us see what the answer is. Someone says 1 over 2. That is Mbulaheni. Hope. Hope got 1 over 2. I think. Yes. This one is question G. Just so that it's easier to make reference. So, Hope Mbulaheni. When you say over 2, is it for that one of G? So you can just confirm on that one if you are referring to that one of G. Then I'll wait for another one to give a response to that one. It says, yes, she got or he got a G as 1 over 2 as the final answer. Okay, then it's fine, Hope, it's fine, it's fine, it's fine. Just so that we cover some more, let us do the corrections. So let's see. I'll just be waiting for other answers as I work it out. Remember, addition and subtraction of powers with numerical basis. So this one also, let me try to expand it or to break it. It seems like these steps, they're just the same. You just follow the same. Anesu also got half. You have 2 to that, and then you have 2. No, not that, but there it is 2. There it is 2. So can you guys see what I did there? It was just to break. Now I need to factorize. So you take out that as common factor, you remain with that 3, and then you remain with that 2 to the exponent -1 over, can also take out that as common factor, then you remain with an invisible 1. There you have a plus, then you have 2 to the that. So that means that cancels with that, and then you remain with that, which is 3 minus 1 over 2 over 1 plus that is 4. So I think what I know is that this one, 3.5, it's like, yes, 3.5, which is what is it? No, it's 5 over 2. Yes, I know it is 5 over 2. How do I know? It's because it's 3 minus half, it ends up being 2.5 over this plus 2 that divided by 5. And we know that here you need to say, you change that sign to a multiplication. This is like over 1, so it's like 1 at the top, 5 at the bottom, and then that cancels with that. You remain with yes. Those of you guys who got it as 1 over 2. Yes, you did get it correct, honorable members. Yes, let me check for this one again. Let me check for this one. Guys, you need to be very quick on these problems. You need to be very, very quick. I think we are making some progress, honorable members. We are making some progress. Let us now look at this one being I. And then I, we are having 2 times 3 to the exponent x plus 2 plus 3 to the exponent x minus 3. Yes, yes, yes. Let us look at that one. Let us look at that one and see ukuthi siyenza kanjani lento le. Siyenza kanjani lento le. Okay. After this one is going to be an interesting one. After Shubala. Kusaso Shubala. Someone is okay. We are now on I. Then it's fine. I'll just be waiting for a response to that one of I. Oh, Mali. Tina's funny man. Oh, Mali. Tina. Okay. Now it's actually the network on my side. Guys, it seems like we might need to cut it short again. It seems like we might need to, this time around, cut it short. Okay, someone got an answer. But guys, am I not breaking? That for I. Okay. Hope, can you clearly hear me? Is everything okay? Why am I suspecting that my network is poor again? Okay, no. Yes, but you are starting to break. Okay. Okay. So, Hope, every time when I start breaking, let me know immediately, honorable member. Let me know immediately so that I'm aware, because now I'm about to do the corrections. I want to make sure that when I do the corrections, everything is clear. It's fine. I see you guys got some answers for me. So let's see if I'm going to get the same answers that you got. Okay, again, what we are going to do is to say 3 to the that, then we still have 3 squared, where you plus 3 to the that, and then you have that to the that. And you just say over that to the that, and then that to the that. Okay, then let's see, can we take out something as common factor? I think we can. What if we can take out that 3 to the that, and then it means we remain with that times that, which is like 2 times 3 squared. We have plus, then we have 3 to the exponent negative 3. You say over, you have your 5, that is multiplying 3 to the that, and then you have that. I'm not sure if you guys notice something. That will cancel with that. So that means you have, that is 9 times 2 is 18. So it's like you have 18 minus, that one, is it 27? I think it's 1 over 27. 3 to the 3. Yes, it is 1 over 27. All of that, it's like this, it's like 5 times 1 over 9. 5 times 3 to the negative 2. Yes, it ends up being 5 over 9. So this one can just punch all of it. So let us see. You start with a fraction pattern and say 18 minus 1 over 27, and then at the bottom you have 9 over, no, not 9 but 5 over 9. I almost made a big mistake. Why am I getting a different answer? 97 over 3. Guys, did I make a mistake somewhere? Hey, you guys have retracted your messages. Guys, did I make a mistake somewhere? The only way to prove it, I'm going to choose a number that I'm going to use and substitute. I will say x is equals to, let us say 2. Yes, so that means everywhere I see x, I'm going to put 2. Say it is a plus, not a minus. Yes, I probably made a mistake somewhere where, oh yes, yes. So there it is a plus and not a minus. So that means now I need to punch that again. So let's see. So you start with a fraction pattern and say 18, you say plus 1 over 27, at the bottom is 5 over 9, that, oh yes, 487 over 15. 47 over 15. User 1234 got it. Larissa, I'm not sure, honorable member. Hope, yes, Hope also got. Okay, seems like we are getting somewhere, honorable members. So that's how you would work it out. Make sure to take a screenshot so that you've got an answer. Let me tell you guys a secret. So this is how I was going to try prove if my final answer is correct. You can use any number there. You can just say x any number. So let us punch this original problem where we punch 2, where we see x, and see if it is going to give us that. Let me test if this thing still works. So that means it's 2 times 3 to the exponent. You say 2 plus 2, and then you say plus 2 minus, not that, but 3, plus 3 to the exponent. You say 2 minus 3, and then at the bottom is 5 times 3 to the exponent 2 minus 2. Yes, can you see? It gives you that same answer. So that means if you will simplify and you want to prove if your final answer as a number is correct, you just choose any number and you substitute where you see a letter. One can use 8, one can use 3, one can use 7. So if you use a number and it gives you an error, that means you need to try a different answer. Try a different answer. Okay, then it's fine. This is what I wanted to take you guys. Let us see. Guys, remember, please, that like button, let's just confuse the enemy, honorable members. I don't know why we should like it, but it's there for us to just like it. I think that will serve as attendance register. Okay, so now let us see. Here now we are solving for x. Solve for x. So this is what we are going to be doing. Solve for x. Maybe let's start with this one and say 2 to the exponent x is equals to square root of 2. Yes. Solve for x. Let us say this one, it is in letter B. Yes, letter B. So that means you will say B, x is equals to wara wara. In case if you've got no idea, you just comment and say no idea, so that I'm aware that you did give it a try, but truly speaking, you've got no idea. Okay, someone got excess half. Okay, let's see. So remember, honorable members, um, when you have square root of something, on the left you have 2 to the exponent. When you have square root of something, there is an invisible 2 there. Invisible 2 there. Just like when you have invisible 1 there, but there is 2. So that means this thing is the same as 2. Remember, there is an invisible 1 there. So what we say is that square root is the same as a 1 over 2. So can you see the bases are the same? Then what you can do, it is to equate. Yes, you did get it correct, honorable members. Okay, let us now look at something different. Let us now look at something different. Let me see if I can find something a bit more challenging. Maybe let's go for this one being f. Let us say 3 to the exponent x plus 1 being equals to square root of 3 over 3. Yes, 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 yes. Let me give you that one. Let us solve for x and see what we are going to get as an x. Remember, honorable members, this type of lessons, they are going to help you in all the different chapters that you're going to be doing at school, because mathematics is always about solving. It's either we solve or we simplify. These are the main two things that we do. I only realized this at a later stage when I was doing some more and more different chapters. I actually realized that when it comes to maths, we are always solving. So with these different chapters, it's just a matter of understanding how the chapter or what the chapter is all about. Once you know what it's all about, the moment you start having an equation, trust me, honorable member, it becomes easier to solve because already you have done a lot of solving. So it saves you time. So while others struggle with what the chapter is all about and also struggle with solving the problems, you are only, you master that, you are done, then you move on to a different chapter where you also worry about what the chapter is all about. So trust me, Bandala, improve your mathematical skills on that, and you are not um, about, we say, I think it's negative a half. Take negative half over 2. Okay. It, it the same answer. My network, is it always you will it's just let us not lose the energy, but let us push and see how far. This should be the last one. Yeah, maybe let's answer for this one. Check. Yes, to check. This one, it is the same as 3 to the power of invisible 1. That's what I did there. So we have 3 to the exponent that. So can you see, you have the same basis. You can represent that as the same base, negative a half. So you take this one to the other side. It's like your x, it is equals to a negative half that you plus it with, not to plus, but you minus it with. Guys, I think let us leave it and with this type of lessons. Tomorrow you are going to be attending the normal Zoom. Substitute that answer. If it gives you negative on the other side, punch the other side and convert it to decimal. That's how you should work it out. This one I know it gives us a 0. Ladies and gentlemen, I need to sign out. This moment is like a x from x repo saying right, ipenseli yaphuma, but we'll meet again tomorrow.